When a raindrop falls, it does so in a way that seems almost perfectly designed to maximize the amount of time it spends airborne. In other words, a falling raindrop takes the perfect path to maximize its hang time. But how do we know what the perfect path looks like? And how do we know when it's actually falling in a way that maximizes its hang time? Well, by breaking down the motion of a falling raindrop into its various components, we can determine what makes a raindrop's fall both beautiful and unique. And we just might discover some surprising math along the way. When the raindrop falls, it doesn't just drop straight down due to gravity. Instead, it falls in a curved path around a central point known as the stagnation point. Now, this might seem counterintuitive since surely gravity is pulling the drop straight down, right? But no! The force of gravity actually pulls the raindrop towards the center of the earth, not necessarily directly downward. And as a result, the drop actually follows a curved path that maximizes its hang time. In fact, the shape of a falling raindrop is so perfectly designed to maximize its hang time that if it were to fall any other way, it would actually fall faster. And that's because the surface of a falling raindrop is constantly changing in response to two competing forces: gravity and surface tension. And these forces are always in a dynamic equilibrium with each other. On the one hand, gravity is pulling the raindrops apart, but the surface tension of the water is keeping it together. The resulting shape of the raindrop is a balance between these two forces. And it turns out that this shape is the one that allows the raindrop to spend the most time in the air. If the raindrop were to fall in a different shape, say a pancake shape, it would fall much faster due to the increased surface area in contact with the air. So, the perfect shape for a falling raindrop is a sphere, or more accurately, an oblate sphere, which is a sphere that's been squished at the poles and stretched at the equator. It's this shape that allows the raindrop to maximize its hang time. And it's also what makes the falling raindrop such a beautiful sight to behold. But the beauty of a falling raindrop doesn't end there. In fact, the math behind its motion is so elegant and precise that it has been studied by some of the greatest minds in history, including Isaac Newton and Leonardo da Vinci. And it turns out that the path a raindrop takes as it falls is a mathematical curve known as a catenary. This is the same curve that a hanging chain takes, and it's also the shape of a rainbow. So the next time you see a falling raindrop, take a moment to appreciate the hidden beauty of its motion and the surprising math that makes it possible.